Hi, in this video we're going to be looking at trig equations. We're going to look at some past paper questions on how to solve trig equations. The first question says determine the general solution. I just want to underline that. Determine the general solution of cos 2 theta plus sine squared theta minus 5 sine theta minus 4. You'll notice most of the expressions have sine. So the first thing I'm going to do here is change the cos 2 theta, since that is a double angle. And we have three choices. We can either use 2 cos squared theta, we could use 1 minus 2 sine squared theta, or we could use cos squared theta minus sine squared theta. And the one I'm going to choose is 1 minus 2 sine squared theta. And the reason for that is that because the rest of the terms have sine theta in them and we see a constant. Okay, so now we're going to group like terms. You got minus 2 sine squared and 4 sine squared. That'll give you 2 sine squared theta. And then we got a negative 5 sine theta, which I'm going to bring down. And then your constants is a minus 4 and a 1, giving you minus 3, which is equal to 0. So what we have now is a quadratic, which we can factorize. We can either use a quadratic formula. You can use your calculator, try and get a factors. And if we factorize this is like saying 2x squared, if you're confused. This is like saying 2x squared, you got minus 5 sine, like minus 5x minus 3. So that's what we're looking at. Instead of the x, we see sine squared. So if you had to factorize that, you would get 2x plus 1 into x minus 3. And we can make sure by using 4, 2x squared, or 1x minus 5x and minus 3. So translating that with the sine, you should be getting 2 sine theta plus 1 into sine theta minus 3. And then we can actually solve the linear factors. The first linear factor, we have 2 sine theta plus 1 is equal to 0. Or we could get sine theta minus 3 is equal to 0. We solve the first one, we take 1 on the other side, becomes negative 1. And then we'll divide both sides by 2, giving us sine theta to be equal to negative half. And the other side, we have sine theta is equal to 3. Now you can use your calculator and check this. If you press shift sine 3, that's not possible because the maximum value for a sine theta graph is 3. So coming on my left hand side, the first thing I'm going to do is determine the quads. Since it's negative, remember sine is negative in quadrant 3 and 4. And our angle formula in quadrant 3 is 180 plus our reference angle. And in quadrant 4, it'll be 360 minus the reference angle. So using my calculator, I'm going to find my reference angle. And I will type in shift sine half. And if we type in shift sine half, we should get 30 degrees. Remember the negative, don't use the negative determines your quadrant. So our answer now lies in quadrant, as we said, quadrant 3, as you can see. So my angle formula in quadrant 3 is 180 plus the reference angle. So we can say that theta is equal to 180 plus 30 plus 360k. Or we could be looking at quadrant 4. And in quadrant 4, our angle formula is 360 minus the reference angle plus 360k. And you got to specify that k is an element of integers. And if we solve that, we should be getting 210 plus 360k, and on the other side we should be getting 330 degrees plus 360k. And there we have our first trig equation solved and left in general solution. All right, we're looking at our second question. It says f of x, is actually equal to sine x plus 25 into cos 15 minus cos x plus 25 times sine 15. And then the question is, find the general solution of f of x equal to tan 165. So we have f of x. All we're going to do is take the f of x and equate it to tan 165. There's no need to be alarmed with tan 165 because we can find that on a calculator. So bring it down. We're going to say sine of x plus 25 into cos 15 minus cos of x plus 25 into sine 15 is actually equal to, and they're telling us that is actually equal to tan 165. So if we look carefully, we see we got sine, cos, sine, and that is the compound angle formula. So if we work that backwards, that's the compound angle formula for sine, and your first angle is x plus 25. There's a negative in between, so we should be subtracting 15. Your second angle is actually equal to tan 165. You can use a calculator on tan 165 or keep it as it is and work with it later. If we use a calculator, we get negative 0.2679. And if we simplify 25 minus 15, we will get sine into x plus 10 is equal to minus 0.2679. So from here, we want to find our reference angle. And remember, if we find our reference angle, we don't use the negative. So if I look at this question, if we type in shift sine minus 0.269, I'm going to actually type that in. Shift sine, don't type the negative, 0.2679, and we get an answer of 15,54. Now remember, the negative is for our quadrant. So we're looking at sine, and we know sine is negative in quadrant 3 and 4. The angle formula is 180 plus your reference angle, 360 minus your reference angle. So putting it together, now remember the angle is represented now by x plus 10. So we're going to say x plus 10 in the third quadrant is equal to 180 plus 15.454 plus 360k. Or we can say x plus 10 is equal to 360 minus 15.454 plus 360k. And we know k is an element of integers. Putting it together, we're going to say x is equal to 180 plus the 15.54, and then we're going to subtract the 10, as you can see on that side. And if we do that, we're going to get a final answer of 185,54 plus 360k. And the other side, we're going to get 360, subtract the 15.54, and then subtract the 10. And if we do that on our calculator, we should get 334,46 plus 360k. And here we have our general solutions. Okay, our next question says determine the general solution of cos 4x cos x plus sin x sin 4x. And if you look at it carefully, that's cos sin sin. That is the expansion of the compound. Sorry, my PowerPoint just skipped a page. I'm going to get back there. Let me get back to the right page. Sorry about that. We're back on the screen. So I said, notice this is a compound angle formula for a cos. So we're going to go backwards with the formula, and then we will bring it down, reduce it to cos of 4x, and we've got to change the sign from a plus to a minus, and that gives us a negative 0.7. So there's our cos 4x, cos x, change of sign to a plus, sine 4x, sine x. So that is our compound angle formula, and we're working it backwards. And that gives me cos 3x to be equal to minus 0.7. Now you'll notice it is negative, and the negative tells us that, or indicates, the two quadrants we're working with, and cos is negative in quadrant 2 and 3. So we have a 180 minus and a 180 plus your reference angle here. So if we work at our reference angle, we're going to type shift cos 0.7, and that should give you 45.57 degrees. You'll notice the angle is 3x. So we're going to work in quadrant 2. So in quadrant 2, we can say that our angle 3x would be equal to, it's 180 minus your reference angle plus 360k. Or we could be sitting in quadrant 3, sorry, that was quadrant 2, or quadrant 3, where we're going to have 3x is equal to 180 plus 45.57 plus 360k. And remember to write k is an element of integers. Let me simplify that. 3x on your left would be equal to 180 minus 45.57 gives us 134.43 plus 360k. And then we're going to divide by 3, and we end up with 44. 134.43 divided by 3 is 44.81 plus 360 divided by k is 120k. And on the other side, 3x will be equal to 180 plus 45.57 is 225.57 plus 360k. And then when you divide by 3, we should get 75.19 plus 120k. And this is our two general solutions for this question.